Hey all, welcome back to your own channel Capsulated Breakthrough. We are back again after a week's break, and today we will be talking and we will be dwelling into the world of electromagnetism, and we will be discussing the introduction of electromagnetic theory, and further we'll be finding out different magnetisms. We'll be talking about the line charge, volume charge, and other charges, and at the end we'll be speaking about the Gauss law, and we will discuss the application of Gauss law in the physical world. Without wasting much time, my name is Syed Irfan. I am pursuing my electronics and communication degree from Sri Venkateswara College of Engineering. And let's start because we know if you've been following our videos, we all know that time is our greatest enemy, right? So, without wasting much time, let's start. Introduction to electromagnetic theory, exploring the fundamentals of electromagnetism and the Gauss law. On to the next slide. What are the fundamentals of electromagnetic theory? What are the basics? See, what before we start anything, it's very important for us to understand the basics of what we are going to start, right? So, the definition of electromagnetic theory is electromagnetic theory is a physical theory that describes the interaction of electric and magnetic fields. Simple. Anything which describes the interaction between an electric and a magnetic field together is an electromagnetic theory. On to the next key concepts. Electric fields, the fields created by the electric charge, magnetic fields, fields produced by moving charges or currents, electromagnetic waves that consist of synchronized oscillations. Let's just discuss on electric field first. Let's go one by one, right? Electric field, fields which are created by the electric charges. Imagine we have an electric charge Q. Let's consider this ring as an electric charge Q. There is an electric field between this charge, which the electric field is the power of the charge till which it can apply the charge is the field of the charge. So we call it as electric field, right? If, for example, if this is my mobile phone, example, let us consider this is a charge, and this has a field. This has a field. Let's take 50 meters of 50 centimeters of the field. That is, it can be actively charged around 15 meters. So this is called its electric field. Moving on to the next, the electromagnetic waves. What are electromagnetic waves? Uh, Waves that consist of synchronized oscillations and electric and magnetic field. Electromagnetic waves have both the oscillations of electric field simultaneously with the magnetic field. Combined together makes an electromagnetic wave. Right? This all the concepts which are very well versed to us. There is no need for us to go through to these again and again. So I'm just discussing this. We'll be dwelling into the main topic very soon. Right? So what are the applications of the modern technology? The applications are as such in the electromagnetic theory is the fundamental to the various modern technologies such as wireless communication, radar system, and medical imaging. See, uh, if you ask me, the electromagnetic applications are diverse and we are yet to explore the biggest part of them, right? We can use them in communication as a vast, we can use them in radar system. We can make our defense system so strong by using EMW in that. These are the other aspects which we can talk some other day, but I'm just telling you, this is a thing which is not explored much, which we haven't exploited it much. And there's a huge possibility and chance in future that electromagnetics can be used in diversified fields. It has a great future, is what I believe, and is what the system believes too. Right? On to the next. Okay, what are the concepts overview is still there. Electric field and their properties. Coming on to the electric field and their properties, right? The first is definition of electric field again. The electric field is a region around a charge. Okay, this has a good definition. Might be helpful, right? An electric field is a region around a charged particle where another charged particle experiences force. Simple, right? It is an area for let me draw and show you that will be more helpful is what I feel. Maybe I just think so. Okay, let's not waste our time again. So it's simple. Electric field is a region around a charged particle. Considering this mic itself, okay, for example, same. Let this phone is a charged particle. The region around it may be a 50 centimeter region where the charged particle, where other charged particles experience a force. which is produced by this charged particle, that area is called as an electric field. I hope you've understood that. On to the properties. Superposition principle. Superposition principle is one of the big property of important property of the charges. The electric field due to the multiple charges is the vector sum of the fields created by an individual charge, right? The electric field of the multiple charges. There are many charges, like consider hundreds of charges. The electric field is vector sum created by every individual charge. For example, one by one, the individual charge created sums together forms a total electric field, right? Then the other properties are magnitude. The magnitude of the electronic field is directly proportional to the charge, creating it's inversely proportional to the square of distance by it. Great. This is a simple formula that magnetic field is directly proportional to charge and inversely proportional to square of distance. Right? Okay. The mathematical expression is E is equal to F by Q, where F is the force, Q is the distance between them, and E is the field strength. Right? The properties another are direction. Electric field, pardon, electric field point away from positive charges and towards the negative charge. It's very important point. These are all the basics of electric field, gentlemen. We are just going very fast in this because I believe that I assume that we already know all these things, right? So electric field points away from the positive charges and towards the negative charge. Moving on to the next slide without wasting much time. Yep. Okay. Now, from here we'll be going slowly and trying to understand what the actual topics are. Now we have jumped onto the main topic. That is the line charge distribution. I've told you line charge, then volume charge. Also, we'll be studying. The first one is the line charge distribution. What do we mean? What do we understand by the line charge distribution, gentlemen? It is the line charge refers to a continuous distribution of charge along an infinitely long line. It is characterized by a charge per unit length. Very simple. Example. Let us try understand that we are communicating that a person A is communicating with a person B, and the charge between them is spread in a line charge. There's a line charge in between them, and through this, the communication is taking place, and the charges are being pulled away from here. Okay, and how does this characterize? It is characterized by charge per unit length. For example, it is charge per unit length, per unit centimeter, per unit meter, based upon the distance you've been communicating the charge, right? So, point number two to understand the line charge is electric field due to the line charge. I hope you understood what line charge is. It is very basic. It even cats and dogs can understand this. On to the next electric field due to the line charge. The electric field E at a point due to a line charge varies with the distance and follows Coulomb's law. Okay, the Coulomb's law is very important here to be remembered. It is inversely proportional to the distance of the charge between them. Very simple here. Okay, mathematical representation is what I told now. It is like the charge density lambda is mathematically defined as total charge Q divided by the length L. Q by L, where we are directly proportional. The lambda is charge density directly proportional to the charge on it and inversely proportional to the length of it. So, what are the basic applications of the line charge? See, we discussed on line charges, we know the formula of line charge, and now the most important thing is where are we using these line charges, right? Anything which we speak things which are being useful in today's generation. So where do we use line charges? Okay, where do we use line charge? Line charge distribution finds application in various fields, including electrostatics, antenna theory, electromagnetic wave propagation, examples including charge transmission lines and lightning rods. See, yeah, exactly. Lightning rods is one of the most, seen example, right? I think everyone has seen the road lamps street lights which are connected each to each through a line charge through a wires which are line charge simple one. This example I would have gone first. Yeah, this is a very common example, right? There are two poles between them which are connected through a wire, line charge is flowing between them, and the electricity is passed on. Simple, right? Now, the sheet charge has a very basic understanding. The definition of sheet charge and mathematical representation of sheet charge will be done, and that is the sheet charge. For example, there's no definition in this. I'll explain you, no issues at all. The sheet charge. No, we've done the line charge, which goes in line. The sheet charge, as the name suggests, the charge is spread throughout the sheet. Okay, and the charge is anywhere the application of the sorry, anywhere the uh, any object is present, if it is present on the sheet, for example, okay, yeah, let us consider this as a sheet of charge. Okay, the object anywhere, if the object is present, the object is kept, right, then it experiences charge towards all the sheet at a concentrated particular point. This is what the sheet charge tells to us, right? And the mathematical representation is a Q by A, the area it occupies, charge upon the area it occupies, electric field due to sheet charge is produced, and the applications of sheet charge are widely versed. Going on to the volume charge distribution. So, what do we mean by volume charge? We've got the line charge, we've got the sheet charge. Now, coming to the next one, which is the volume charge distribution. Understanding the distribution of charges in volume. Definition of volume charge is it refers to the charge of distribution within a given volume of space, right? For example, we've given a volume of 2 liters of space, and the charge experienced by this volume is called as the volume charge. Very simple to understand is what I feel. Sorry. Yeah, next. Sorry for the disturbance caused, guys. These kind of things keep happening by me. I'm really sorry to disturb you. Coming back, electric field due to the volume charge describes the electric field generated by the charge distributed throughout a volume. For example, okay, so this is a cylindrical box, right? This is its volume. I hope you understand the cylindrical box, the volume. Okay, what this tells? Describes the electric field generated by a charge distributed throughout the volume. This is throughout the volume. For example, a charge Q is distributed in this whole volume. Then the charge that is spread in the whole volume is given as the volume charge. I hope you've understood with the example. The mathematical representation is that charge density is equal to Q by V, that is charge accumulated by the volume. Okay, applications and examples illustrate real world scenarios where understanding volume charge distribution is crucial, such as capacitors and dielectrics. Okay, moving on to the next one. Understanding the Gauss law. See, this is something where I want all of the focus to be driven now. Till now, what we understood was very easy, very basics, going very smoothly is what I hope so. But Gauss law is something very important. It is usually asked in examinations. This is not for the examination purpose. This is just for understanding purpose. Here in this channel, in the videos we don't give any notes. We just make you understand how and why and what is happening. The notes will be given by your teachers. Kindly read that, right? So, understanding the Gauss law. See, if I also had to give notes, then I would have written get a whiteboard and teaching you. No, my purpose is just to give you knowledge, just to install the knowledge into your head that this is what the Gauss law is. This is what line charge is. Definitions I've been giving, but the writing part will be given by your teachers. Contact to them in any case of harm, right? Yeah. Okay. Next. The statement of Gauss law describes the relationship between electric fields and charges. Simple. The Gauss law gives a relationship between the electric field and the charges. I hope this would be easy to understand. It's just a relationship between the electric fields and the charges. Charge and the field, the relationship of these two is an Gauss law, right? Okay. Or the mathematical formulas expressed by the surface integral of the electric field over a closed surface equal to total charge enclosed divided by the permittivity of free epsilon, that is permittivity of free space, right? There's no writing patterns. I would have written the formula also. Fine. Okay, I'll drop in the formula, guys, in the comment section, and I'll pin the comment. Don't worry about that. Okay, the physical interpretations illustrates how electric field interact with the charges and how they are distributed in the space. Okay, this is the physical interpretation of the Gauss law. Then the significance. What is the importance of the Gauss law? Why Gauss law is important? That is, highlights the importance of the Gauss law in understanding electric fields and charge distributions properly. If you have to master the charge distribution and electric field, Gauss law is your Brahmastra. Without Gauss law, there is no existence of electric field, is what I believe. We read Gauss law in ninth, 10th, 11th, 12th, and in engineering too. And I think further also Gauss law is very important, will play a crucial role because I am an engineering student. Okay, the applications of Gauss law. See, Gauss law has a variety of you can be seeing in the screen. These are just one of some of the explanation which I found, interesting. So I picked up in the slide. But Gauss law has huge application, very big application. We'll be discussing on some other day, some other video. We'll make an if in case if you request, we'll make a separate video for Gauss law itself and its application we'll discuss. But in today's video, as we know that we have time constraints, okay. So calculations of electric field, that is understanding the process of determining electric field using Gauss law. So what is it? What does this huge statement tell? Understanding the process of determining electric field using Gauss law. See, every charge has its electric field. Basics, we know, no doubt about it. Now, the understanding of having an electric field depends upon the electric charge. This is what the calculation of electric field is. This is what the statement tells, that the electric field is understood by the charge which is being placed there, right? Next, the symmetry consideration. The symmetry, this please symmetry, okay, in our childhood there used to be an activity where we used to make that, the symmetrical thing that we used to place a triangular shaped mirrors, okay, and put some chunkies into that, and we rotate and we could have seen beautiful patterns. So symmetry plays a huge role, and sorry, Gauss law plays a huge role in symmetry too. Let's see how. Ex Examining the importance of symmetry in applying Gauss law is simply simplify calculations. Okay. Then, spherical symmetry, symmetry again. See, the different symmetries: spherical symmetry, cylindrical symmetry, and planar symmetry. Spherical symmetry, where illustrating Gauss law application in scenarios with spherical symmetry, and then cylindrical symmetry, exploring the Gauss law in context of characterized cylindrical symmetry, and in planar symmetry, applying Gauss law to situations, exhibiting planar symmetry for a practical insights. So there are three main major is what I got the sources through the information. That is planar symmetry, cylindrical symmetry, and spherical symmetry. Symmetry is one region where Gauss law plays a major applicational role, right? Without wasting much time, there's no time to waste, and we already have arrived to the last slide of this video. I think we've already taken 20 minutes of time, which again constrains the time limits, right? So this is it for today. We've spoken about the electromagnetic theory, the basics of magnetic theory. We've rebrushed our brain to the basic terms, like what is charge, what is electric field, magnetic charge, and then we've come to the plane charge, volume charge, and line charge. I hope you have understood these three basics really cool, because these are important. Then we've come to Gauss law. In Gauss law, gentlemen, we haven't discussed Gauss law to the extent of depth, because this video was not only about Gauss law. I have just given you a brush up on what Gauss law is and its application. If you guys demand a video for Gauss law, we'll surely make it, but try to understand this channel's purpose is not to provide you notes, not to provide you formulas. This channel's purpose is simply to make you understand the concept behind this. What does this do? Because once you got the concept in head, formulas and applications are not a big deal at all, is what I believe. So that is it for today's video, ladies and gentlemen. This is me, Syed Irfan, signing off. Until next video, see you. Sayonara.